Shivani Shri. I am today going to speak about the topic mathematics in cosmology. Physical cosmology is the study of the properties and evaluation of the large-scale structure of the universe. It firstly determines in the light of astronomical observations what is there when we average out the matter distribution to the largest scale. Secondly, what its history has been in the light of your understanding of physical forces. And thirdly, what its future is likely to be. Thus it has descriptive and dynamic aspects supported by theory and observation. Modern cosmology is a mathematical physics subject, so we present the mathematics used in these studies. However, we try to clearly link this into the underlying conceptual principles on the one hand and the observational test of the resulting models on the other. Basic assumptions. As with all sciences, cosmology has its base certain philosophical method and assumptions that order in nature. Broadly, these are the assumptions and processes that generally underline the scientific method. In a particular case of cosmology, a mathematical model of cosmos is proposed based in our current understanding of the relevant physics and the data so far. This is then tested in detail against observation and is adopted only if it explains those observations satisfactorily with suitable values of its free parameters. However, because of the particular nature of its object of study, there is only one universe accessible to observation. The specific form of the assumptions made is particularly vital in the case of cosmology. Foundation. The core principles underlying standard cosmology or physics is the same everywhere in the universe. This is not obvious because cosmology covers such vast time and distance scales going back to the start of the universe and to immensely larger distance than the solar system. But without this assumption of universality, we could not undertake a scientific study of the universe in the large. This assumption is tested by the success and coherence of the resulting models. For example, the precise black body spectrum of the cosmic black body radiation confirms that statistical physics and quantum physics were the same 13 billion years ago as they are today. The large physics that applies everywhere determines the dynamics of the universe in the large. That is, there is not a cosmological physics that applies only on large scales. Rather, large scales dynamic emerges in a bottom-up way from the combined effects of local dynamics on matter everywhere on small scales. Gravity is the dominant force in the universe on solar system and larger scales. This generalizes to galactic and cosmological scales the finding that gravity dominates the solar system. This would not be true if astronomical objects are electrically charged. For example, if electron and proton charges were not of precisely the same magnitude, in that case electromagnetism would be the dominant force on large scales because it is a much stronger force than gravity. Gravity is the classical regime is well described by general relativity theory. So this is the theory that best describes the geometry and dynamics of the observation universe. One represents its evaluation by using the Einstein field equation to determine the effects of gravity together with models of the local behavior of matter, which are the source terms for the gravitational field. This assumption, because of the equivalence principle, encodes 1 and 2. One consequently has to consider a general relativistic model with geometry and matter description suitable for a cosmological context, and the Einstein field equations determining the dynamics of the model as to the nature of the universe. The universe is of vast size and age, with the solar system a tiny speck in a mostly empty space-time. Our observational access to the universe is strictly limited by visual horizons and the opaque nature of the very early universe. Our ability to test the relevant physics uh, at very early times is limited by practicalities in terms of what practical accelerators we can construct. Thank you.